So let's look at these three that talk about the bisectors, the bisect, because that is a really kind of a picky thing that I want you to pay really careful attention to. So given that BD bisects the angle, never ever assume things in geometry. So what we have is this BD is going to do the cutting. This gets cut. So we are going to cut in this direction. That is all you know. So what I know from that information is that this angle is going to get cut in half. So I know that angle ABD is equal to angle CBD by definition bisector. I know nothing about that segment back there because that is not what my given tells me. If you go ahead and you look at number 5, we'll come back to number 4, look at what this one says. BD bisects this segment. Now my segment BD is cutting in this direction and it's cutting this segment. So what I know now is that that segment gets cut in half. So my conclusion is that AD is equal to CD by definition bisector. Words to a conclusion by the definition of the thing. So just be really careful in doing exactly what it says. So down here, number 7 rather, number 7, given diagonal AC bisects diagonal BD. Not that they bisect each other. AC is going to do the cutting on BD. So A to C is going to cut BD. So what we know is this, that DE is equal to BE by definition of bisector. How do I know it's definition of bisector? Because my words told me I had a bisector. Words to the equation. If it has words to an equation, it's almost always definition of whatever your word is. So let's go back and look at number 4. Given angle 1 and angle 2 are complementary, what can I write? Words and a picture to the equation. Complementary means they add to 90. So I write angle 1 plus angle 2 equals 90. Words to an equation. Definition complementary. It is the definition of complementary that lets me write this equation. Take a look at number 6. Given E is the midpoint of AB, what do I know if something is the midpoint? Means it's in the middle. If E is the midpoint of this larger segment, right here, I know what's in the middle, which means these two are the same. So I know that AE is equal to BE. Now we've written some segment equal pieces before and they were by definition of bisector, but that's what the given told me. In this case, the given tells me midpoint, so my reason that lets me know this to be true is the definition of midpoint. Because they told me midpoint, that told me pieces were equal. So the reason I know it is because the definition of midpoint. So words to an equation, definition of the thing, parts to whole. So we have all of these tools. We have linear pair, we have parts to whole, definition of complementary, definition supplementary, definition of midpoint, definition of bisector. So we're starting to get lots of tools to be able to describe and work with geometric figures. So let's do our first official geometric proof. This information shouldn't be here. All right, so we have that Q is the midpoint of PR, R is the midpoint of QS, and we want to prove PQ equals SR. We don't know this. This should be our very last line. So we always start with our given. Make my T-chart. I'm just going to write the given down. Q equals midpoint of PR. R equals the midpoint of QS. And those are given. Now, what does the given give me? If Q is the midpoint of PR. And the first thing you're saying, well, that isn't what the picture looks like. Pictures lie. Always go with the words, except when it comes to vertical angles and linear pairs. Pictures lie. So if I know Q is the midpoint, I know that PQ has to be the same as QR. By definition, midpoint. So this piece of given, let me write this line. What is this piece of given? Let me write. R is the midpoint of QS. So if I look at this segment, if R is the midpoint, then this piece and this piece are the same. QR equals RS, also by definition of midpoint. You notice how I mark the hash marks on my pictures? Look at what I have. 2 hash marks, 2 hash marks, 2 hash marks. PQ is the same as QR, and then QR is the same as something else. I could replace this by substitution. If those guys are all the same, wherever there was, I'm going to take this one, equals RS, but this time instead of QR, I'm going to say PQ. Because PQ is the same as QR, QR is the same as RS, so I can say those first and third are the same, and look at what I want to prove. Remember, SR and RS are the same thing. What did I do there? What's my rule that lets me do that? Substitution. This substitution business right here is like 4 quarters and $1, $1 and 10 dimes, and we know that 4 quarters and 10 dimes are the same. It's replacing equal valued items. You just did your first geometric proof. So let's look at one more. Given that AB equals DC, prove that AC equals DB. Now, I really like highlighters and colored pencils. So I'm going to highlight this. I want to say that A to C is the same as B to D. Now I do it like in a yellow so I don't mistake as knowing it, but it just gives me a visual of what I want to try to prove. And I want to prove that those overlapping pieces are equal. And the key is that they overlap. I bet that whole key is that they share that BC amount. So that's kind of interesting. So AB equals DC. AB and DC. So that's given, so I can mark it. So set up our T-chart. And we're going to write that AB equals DC. And that's given. Now, AB is connected to AC. So I could write a parts to whole statement. And I could write that AC is equal to AB plus BC. Now, why would I think to do that? Well, I want to say something about AC, so I better write down what I know about AC. And I know that AC is equal to its 2 pieces. I could do the same thing for DB. So let's write down what we know about DB. We know that DB is equal to its 2 pieces, which are DC plus BC. Now, proofs aren't a formula, but they do have patterns. And the more proofs you do, you'll start to see these patterns. And a big pattern is to get equations and do a substitution and get one side of the equations to be the same, and then do another substitution. So when I start looking at these things, remember this piece right here, that AB and DC are the same? I already have the exact same BC part. What would happen if I replaced that AB with DC? That's the only thing I'm going to change. So I have AC equals DC plus be C. Whenever I replace, that's substitution. Look at this sum right here, that sum right there. Those are exactly the same. So now I could replace again, and look what happens. If DB equals this sum and AC equals the exact same sum, then by substitution, AC equals DB by substitution. And you proved what you needed to prove. So even though the picture was totally different, that idea of writing a couple of equations, making a substitution, and then making another substitution was what we used in the first proof and in the second proof. So it's a really powerful pattern that you see, not a formula, but a pattern. That's your introduction to proofs. Good luck with your homework.